Hello, welcome.
What's up,
Uh,
friends?
Yay! First Enlightning episode of 2023. It's going to be a good year. I'm here
Oh,
today with my friend and my teammates, Lee Capili, and we're going to be talking about the Carvel toolset. Did I say that correctly? Carvel?
yeah. Yeah, it's
Woo!
definitely hard to pronounce properly term. But I think if you say Carvel, that's still cool with me. Right?
I think it's more common to have that problem of not of there a couple different ways something can be pronounced than to not have it for all the CNCF tools.
Oh man,
So
yeah. I mean, we're talking cloudy tools, right? You've got like Cubectl, right? And then there's Kubectl,
does someone say Hubectl?
Kubectl. Some people are
It
like
sounds
Kubernetes. Other people are
it's
like Kubernetes, and it's like
Kubernetes.
common. Yes. Yeah. Flux. Yes. I was deploying Flux on a cluster yesterday. Yeah. So shout out for
uh,
all you Flux. Yeah. So
for container D, I legit thought that was containered for the longest
yeah,
time because I just
which
read
is
about it
fair.
forever.
And then now we have nerd CTL, right? Or nerd control or nerd cuddle.
Yeah, you got to lean into the nerd thing, I
Yeah,
think.
they have the command line tool that emulates all of the Docker kind of bits, makes it feel just like using Docker, but it's just straight up containerd. Yeah, check out Akihiro Suda's NerdCTL, which is now part of the containerd project.
Yay! So let's say
For all
hi
you
to some folks in
nerds.
chat. Let's say hi to some folks in chat. Hi,
Yeah,
Lisa.
a bunch of
Welcome.
popping in here. What's up? Thanks for joining.
Hello, Sumik. Yes. And Feel Stable's here to say just hello. Not enough bandwidth to watch the stream today, but here to say hi. Thank you always for supporting Feel Snobble. And Feel Snobble says cloud native problems I got all day. Maybe you can catch up later because we have some help for you. So here's the thing. I want to ask you, Lee, but also folks in chat. So my family, we don't do New Year's resolutions. Instead, we do a theme for your new year because it's not so pass fail. Like it's not something you can get wrong. It's just like what's something throughout 2023 that you want to prioritize that is important to you, an area you can improve in. So what's your theme for 2023?
One of my themes I think I can point to is mobility. So
Mobility.
I have some sub goals around snowboarding, around like just various physicality and parkour related things.
Nice.
If you don't know me, friends, sometimes I'm in the parkour gym or I'm practicing parkour. I like snowboarding because I live here in Colorado. And so, yeah, our friends have been hitting the park. I've been doing a lot of teaching up at Copper Mountain. And then I've been doing time trials again at the parkour gym and kind of growing with the community there. So I want to get a couple of things in the mobility area this year. I want to get my muscle up back and stuff like that. So.
That's amazing. You and I mentioned before, we're on the same team. And so we often are in the same city. And I love being in the same city with you because you and I find like Dance Dance Revolution machines to do together, or like we go to the bouldering gym. And that's super fun to me to have a buddy. Also karaoke, unrelated, but that's always a a happy reason to be in the same town as you. So
yeah,
that's
I'm stoked
super cool.
about syncing up and hitting the rock climbing gym. That sounds really fun. Of course, we
Yeah,
got to go in. So
yeah, you'll be in Austin with me soon. So we'll do that. We'll climb together before the month is out in just a couple weeks. So we have a lot to cover with Carvel. There's a lot of amazing stuff going on. So we should probably get behind the board sooner rather than later. But is there something you can tell us that's not so juicy that it needs to go on the Carvel on the board, but maybe sets us up, or maybe just a good story? But will you monologue a little bit while I move?
Yeah. I
Behind
love this. I think this is the best way to start talking about Carvel.
Okay, great.
Yeah, so I've been using Kubernetes or Kubernetes or
Kubernetes.
Yeah, since 2016, 2017. And before that, I was a DevOps practitioner of many other tools, just straight Docker. I was a Docker Swarm fanatic. We used a lot of AWS, a lot of vSphere. I was working with telcos. I was working with broadcasting. Eventually, I got into the music industry a little bit. And whatever it is, if you're using ESXi or you're using virtual machines just straight through Linux, KVM, and all that, you're talking about clusters, and you've got different environments, and there's zones in your machines, and like all these different data centers, and so before we were ever thinking about containers, we still had Puppet, and we still had configuration management. We were still writing Ansible and doing all of these other first-gen DevOps tools. And I think if we've got any infrastructure people on the stream, or if you're joining us afterwards and you are like an operations practitioner or some DevOpsy type person, it might even be in your like job title, even though that doesn't make a lot of sense. You know pain. And I know that because I have been you and I felt a lot of pain. It's almost like the job of getting the application like into the environment so that it can go and do the thing to serve the users or transform the information or whatever your business logic or organizational goal is. Like there's all of this glue work, and you have to like pull all of this stuff together and try and keep sorted all of the different sub goals and destinations and artifacts that you're trying to accomplish and trying to ship. And it's just, sometimes you're like, you have to take a deep breath and just only think about like the 2 or 3 bits of the problem that you're gluing together at this one moment. And then sometimes you spend like 4 hours with your teammates whiteboarding for whatever reason so that you can build a better mental model. And I think it's from that place. It's from that pain and from those experiences and from that legacy of problem solving that Carvel comes from. And that's why I get so excited about it. I think the real reason that I started doing demos and talking and volunteering in conferences, a lot of it was just copying my friends and the people I looked up to, but I really just didn't want people to feel the same pain that I felt so much over and over again. Like I thought, hey, maybe we should continue in this like communal sharing thing, and then like stuff can suck less for all of us. So Carl is really exciting in that
way. Carvel, nothing forms bonds like shared trauma or fixing shared trauma. We have a request from Fuel Snobble in chat. He doesn't have bandwidth to actually hear the stream. This is a big ask, and I doubt Fuel Snobble, someone's going to do this for you. But if someone wants to do a real-time narration of what's happening, Findle, Fuel Snobble is asking for that. And Findle, hello, it has been ages. Thank you for coming. I'm so glad to see you. Maybe you can help Fuel Snobble. I know y'all are buddies. Okay, so what? Maybe let's boil down what you just said into one sentence. Carvel helps solve a lot of the pain points of deploying to Kubernetes, or ease a lot of the pain points of developing to Kubernetes. Do you think that is accurate?
I think that's fair. I do want to modify and say that it's just cloud native problems in general. Carvel's not specifically Kubernetes targeted. Like it solves so many Kubernetes related problems that you can say that they are Kubernetes tools. But I think that one of the biggest strengths of Carvel is that it's a skill set that you can take with you beyond your Kubernetes cluster. Into say GitHub Actions, or if you are in a Docker Swarm or Nomad environment, or any place where there's YAML, any place where there's container images. You definitely, like a Circle CI config, you could totally use the Carvel tools for those same configuration glue issues the same exact ones that you have in Kubernetes. And a lot of that is because Carvel is made up of individual tools. And I think that this is super smart. And if you've ever heard of the UNIX philosophy, if you look at the individual command line tools that we use every day, these tools have been around for ages. We've even swapped some of them out. We've improved them. We've rewritten some of them. But altogether, they let us do really cool programming with our Linux computers. And so Carvel uses that same idea, but uses some cloud native interfaces instead, so that we can do really cool programming with our cloud computers. And I'm really, really excited about the different subproblems that these tools address.
We have a question in chat for you, and that is, what is a clean tool? What does it mean that these tools are clean?
Yes. I think that the best way to answer this question is to first think about a tool that feels messy. And tools that are messy often have, there's this fancy phrase that people always use called a leaky abstraction. It's where like the tool is doing so many things, and the abstraction of what it's trying to do at a high level, right? The problem that it's solving for you gets maybe a little bit too specific. And now something about the problem that you're solving changes slightly. And the tool becomes fundamentally broken or fundamentally unusable in some way. Like say you were using a tool that like sends file from a computer to another computer over a Wi-Fi network. But then you're using that tool and you go to somebody else's house and you're like, oh, cool, I want to send a file from this computer. And that Wi-Fi network uses different encryption than normal. And now it doesn't work. Well, that's kind of not that fun, because the tool was so specific and it combined so many details together. It got rid of a bunch of stuff that I had to think about, but then I tried to use it in basically a very expected and similar environment, and I can't put in the web password instead because the encryption is too old. You know, and there's also tools that just are doing too much in the same place. And sometimes it's very powerful if you've got like a very specific workflow. But then you've got like some very, very similar problems and you want to like swap out this one piece. Then that starts to get a little bit messy, right? So when I think of messy tools, it's like interfaces that are not the same, things that are doing too much, details and knobs that I should be able to turn that aren't available to me, and stuff that I can't swap out. That's what I think of when things are messy.
Okay, so what I'm hearing is too that the idea of a clean tool is very similar to this Unix process model emulation, where the Carvel, if it was one big tool, it would be a messy tool if you had to use everything, because then you're pulling in, to use the tool, you have to pull in a lot of processes that you don't necessarily need if you only want to use one aspect of the tool. So you're just getting as much as you need and not more, but then it also fully integrates with the other tools in the Carvel ecosystem.
Yeah, I mean, if you are doing a lot of cooking, you probably don't use the Swiss Army knife to cut your carrots, right? Now, Swiss Army knife is a very useful thing to have if you're camping and you forgot your knife, right? Because then it's like, okay, well, I can make do with this. But wouldn't you really prefer to just have the thing that's specifically cutting vegetables, and then like, you know, you could have your meat knives on the side or whatever as well. Yeah. And so, I mean, like, if we want to be real practitioners, you know, like we should use some tools that are like really designed for us, really help us solve specific problems.
So Carvel is a suite of complementary composable tools.
Yeah. So Thindle, you mentioned Carvel is a clean tool. The short of what I'm saying is I have no idea yet. And they're talking about clean tools. And this is almost right. Carvel is a overarching project that pulls together a lot of individual tools. these individual tools all solve specific problems or specific problem spaces when you are trying to do interesting things with cloud computers. And all of them together kind of give you this Carvel experience. But yeah, Carvel is a set of clean tools.
Just to help my mental model, how big like how many tools are there in the Carvel set?
I think we've got 6 or 7 at the moment. Let's just go and double check that really quick. So I'm going to go to carvel.dev. And right now we've got a portfolio of 6 command line tools and 5 command line tools and 2 controllers. So there's controllers being the thing that you would install probably into a Kubernetes cluster or around or towards a Kubernetes cluster. Yeah.
Cool. So Carvel is 7 tools that most of them are CLI tools that help ease the pain of deploying applications to the cloud. That's great.
Yeah. Deploying, managing, configuring, variating, all of the things that you want to do, the little actions that you need to make your app do the stuff.
All right. Carvel, the little actions you need to make your app do the stuff.
Make your app do the stuff. Yeah.
Excellent. We cracked it. Okay, so are we going to go through all and talk about each of these tools?
We're not going to talk about
highlight
one of these tools, but yeah, let's get a few highlights. And I would say that the first couple of tools that you might be interested in are going to be surrounding the immediate problems that you have when you are first creating a containerized app and thinking about Kubernetes or the place you're going to deploy it to. And one of those first tools, I would say, is going to be, it's either going to be Kbuild or it's going to be YTT. YTT is worried about configurations, and Kbuild is worried about container images and how they relate to your configs. So these tools are very similar to in problem space, but they're separated because they're actually completely different domains. And you'll see why as we talk about it. So let's first talk about the container image one, actually.
So Kbuild?
Yeah. Let's talk about Kbuild. No. Let's talk about YTT. Sorry. I'm flipping. We're moving.
It's
different arrows coming on the screen.
YTT.
So this is an acronym that sort of stands for like YAML template tool. Right. So the Y in YTT is for YAML.
So I normally like to start a show by being like, what is the problem that this tool is solving? And answer, like getting context for what the world looked like before the tool. But in this episode, we're talking about a lot of little tools. So I'm going to ask this question over and over again. So with YTT, please paint me a brief picture of what the world is like before it exists that made this tool come into being.
Oh, yeah. I mean, I think part of our audience, at least, is a bunch of Kubernetes nerds or people who are trying to figure out what to do with their Kubernetes environment that they've been thrust into by their Fortune 100 company or whatever. Or maybe you're a startup just decided that Kubernetes is exactly what they need. And the cool thing about using Kubernetes is it's got this cool programming model of like declarative configs, right? That just tell the computer what to do. And that's fun because now you don't have to learn 14 different Linux subsystems to deploy your app. You just have to read these APIs and put them into a repository or something. So you've got deployment objects, you got service objects, you have config maps, you've got secrets, and your app has multiple pieces. So maybe you have multiple deployments and multiple secrets. And then also you have 3 clusters because there's dev, stage, and production. So then you needed like a couple of copies of these files because they weren't exactly all the same. And then also your Kubernetes clusters, they all need some add-ons, all of them do. right? So you got to install the CNI, and you have to have the ingress controller, and we want to have Prometheus so we can monitor things, and then we're going to probably put a log shipper in there because we pay a lot of money to Datadog, and then we're going to do this, and we have to have this, and we put this CRD that somebody wrote in, and at the end of the day, you just got your 3 clusters running your app that has its 5 components in 3 environments, and you multiply that all together times 50 for each document of YAML. And I think you get something like 4,000 lines or maybe 15,000 lines of YAML.
Wow.
Roughly. Something like that. You know, and it's because the YAML, the documents, the stuff that actually, we might have to ban this user real quick.
Oh yeah.
Block user. There we go.
While we're taking a break, I want to say hello to Napalm. Thanks for coming, Napalm. Happy 2023. We talked up top about what everyone's theme is for the year, or people say resolution. I like theme, so I'd love to hear yours. Okay, back to business.
Oh, back to 15,000 lines of YAML.
Yeah.
Oh. Everyone's excited about that, right? and you know, it's like the computer needs those 15,000 lines of YAML. In fact, it's not just one computer. We've got like a bunch of them, right? A bunch of distributed Kubernetes computers. It needs the instructions. We have to give computers specific instructions. When we look at the amazing things that our laptops do for us, right? They're performing way more than 15,000 instructions every moment. And so there has to be some sort of assembly language, right? Something that we compile, right? If we want to do complicated stuff with cool computers, we got to compile to very specific instructions. But the YAML, even if you ask like the Kubernetes like founders and the initial members of the project, you know, that decision to expose these objects like that, it wasn't intended to ever be like the way that people talk to the computer, right? We've got to have ways to get to the descriptions a little bit easier than copying and pasting this stuff over and over and over again. But right now, the ecosystem is still new, and every project has to talk about their API that way. And so that you have the full power of things. But what you're missing is the programming language. You're missing the ability to talk about these ideas at a higher level, with the ability to do conditionals, so that now you can do the variations between your environments. You know.
So I was going to ask, and I think you just answered. So I know there are other tools in this space, like Helm, for example, or Customize. And it sounds like YTT is a way to deal with configuration with conditionals when those other 2 tools don't have conditionals. Is that correct?
Yeah, so conditional, loops, overlays, all of the kinds of different operations that you're craving for when you want to start munging and variating these configs and declarations that program the Kubernetes computer, or that program the GitHub computer, or that program the Circle CI computer, or the Docker computer. Or you see, like I'm very excited about this because this is one of the special things about YTT, is that it is not necessarily a Kubernetes specific tool. It is a YAML shaping tool that is really good at the kinds of problems that Kubernetes is happy to give you. And so if you're using Kubernetes, you're probably using tons of YAML. You have YAML problems, I promise. They're not Kubernetes, they are YAML problems. And we can get good at solving those YAML programs with a programming language and a tool like YTT.
I want to get like a succinct definition, but I'll say hi. Napalm, congratulations on your new job. That's amazing. It sounds like a great year, great priorities. And Vice Veric, thank you for coming. This has like been such a joy to have all the regulars come say hello in 2023. I love it so much. Happy New Year. So YTT has conditionals. It's a YAML shaping tool. Is it a programming language? Like, help me come up, please, with like a succinct sentence for what YTT is.
Yeah, YTT lets you shape YAML so good that you can program your cloud computers, right? It is a programming language, but
Okay.
it is a YAML native programming language.
YTT is a YAML native programming language? Is that what we should write down?
I think that that's pretty good, yeah.
Okay.
And I honestly think that that's one of the most attractive things about YTT is that it's, I would call it YAML native almost, you know, like it's actually, this is a little bit of trivia almost, or you know, it's not necessarily the most important thing to know about YTT, but YTT is a programming language, which means you have to write programs. That sounds scary. But every YTT program is a valid YAML file. Like you can put it into a YAML parser. You could potentially even apply it directly to Kubernetes. Like,
will you say that every what is a valid YAML file?
Every YTT program is a valid YAML file. And that's because we basically change the way that the YAML gets templated with comments that have other statements in them. So we use YAML comments to then run the YTT program, and those YAML modify the way that the YAML looks at the end of it. And the programming language that's used inside of the comments is something that a lot of infrastructure people are very familiar with because it feels like Python. We use a config language that was designed specifically for this purpose, originally at Google and then given to the community, called Starlark.
Cool.
I'm like intrigued in what you're writing here. YAML native programming language. We have conditionals to your YAML. Specifically using Starlark. Yeah, that's totally right.
A Python-like language.
Yeah. So the fact that it's similar to Python means that a lot of the stuff that people like about Python that is also very similar to YAML blends really well in with the YAML. And the fact that all of the actual programming stuff that makes the YAML smarter than regular YAML, that turns it into the YTT program in comments. And so all of it's valid YAML. That means like a normal YAML syntax highlighter will still look good on a YTT program. Like that means like if someone who has never touched this thing before, like opens a simple YTT program, they can actually probably figure out what's going on.
Cool. I have a question
and learn like completely new stuff. Yeah.
I have a question and Ficeferic has a question. Let's do Ficeferic first. YTT is programming code pattern matching tool. So it sees an expected command and then it processes the syntax and templates them. Is that accurate?
Sort of. Yeah, I mean, I would say so. Like it's it's not just like a simple tool, honestly. Like from the ground up, YTT has been built like a programming language. So it has a parser, it builds a syntax tree, it moves different nodes around and then like passes it to an execution engine. It's the Starlark execution engine, but it does things to make that compatible with the YAML input. And then it always outputs YAML as well. So,
okay, so I have two questions now. One is, will you give me an easy example of some sort of conditional that you might write into your YAML that will, and then what YTT will do with it?
Oh, this one's so good. Yeah. So
Okay.
say that we have a deployment that we want to put into our development clusters that just run on our laptops. But then that same deployment with pretty much no changes except for this one little thing, we want to put it into Google Cloud, into a GKE cluster. And GKE has all of these cool annotations and options and things that you can turn on to make your workload get the benefit of the platform. And this deployment and service that we have, I'm going to add another object in here because the service is the important part. The service that hooks up to the deployment, it needs to have this annotation on it that enables an internal load balancer.
Oh, only if it's on Google Cloud.
Basically. I mean, if I put it there and I put it into my dev cluster, the annotation is not going to do anything, right? But this is this very simple case, right? Like we really only want to put the annotation there if it's in Google Cloud because that's what it means. So in YTT, I could take my deployment manifest with my annotation and I could comment over it that says hashtag, right? Or octothorpe or whatever you want to call that. You put it right over the annotation and you just comment the annotation like you would be describing it, right? Like if I had this normal manifest, there might already be a comment there that says this annotation is only needed in Google Cloud. Well, now I can add a comment there that says hashtag if data value Google Cloud equals true. And then I could even say if/end, and then after I could comment end. You know, there's multiple ways to do it because it's a program. And then when I actually run YTT on that YAML file, the annotation would disappear until I add a data value that says Google Cloud true.
Where does that data value live?
So the data value can come either as a command line option or as a values file. So the values file is something that's probably very familiar now, right? We pass configs to our programs. So in Helm, the values file is so important. We usually have these text templates in Helm, which is a very different kind of programming than the thing that YTT lets you do. It actually, it was the most general thing available at the time, and back when the original authors at Deis built Helm, they just chose text templating. That decision turned out to be a little bit unfortunate because it's just not a really great way to solve the problem. But yeah, so, but text templating, it lets you do the same kinds of things that any programming language lets you do, similar to YTT. Like you have conditionals, you've got loops, you can do indirections, you can make functions, you can do all of these things to repeat logic around places. And yeah, you can do all of that with YTT. And then we just plug our data values in and the behavior of the program changes. So
here's, I have another question. Oh, sorry.
Like that simple example can then go out to more conditionals, right? And then if that got super long, you could pull that, 5 or 10 conditionals into a function that says like decides load balancing strategy. Then you could call that function there instead. And so your YAML can like grow with you and grow with the complexity that your environment asks of you.
Did I conditionals, loops, functions, basically anything a program language could do happens with YTT, right? Cool.
Yeah.
And then my other question is, if you subscribe to the GitOps model, can you still use YTT, where you define all of your configuration in a Git repository and then use something like Argo or Flux to watch? That it does work with that?
Yeah, so you do have to make a decision here, which is whether or not you want your programs evaluating at runtime or if you want to run them beforehand. So if you want to pre-compile your software, you can kind of vendor it into your repo. So like some people, like they would like check node modules, or they would check all of their Go packages into their repository. So you could, or like a lot of front end engineers will like build their front end and then potentially check it into a deployment repo or something. So you could do that. And at the end of the day, the output is YAML. So you can still check your 15,000 lines of code into a repository where you can diff it, you can comment on it, you can pull requests and criticize, compare it against alternatives and that kind of stuff. I actually think that this is almost the preferred and really powerful workflow. There are, of course, cons to this. And if your repos aren't split up properly and at certain scales, maybe it's not going to work for you at all. I think it's a good choice, at least to start out, by just running your YTT program and checking it into a folder. Because then if someone's confused about the source code change, they can look at the vendor folder or the YAML config folder where all of the large changes are, and they can actually see what the differences are in the output. Now, you can also do this stuff at runtime. And what I mean by that is your GitOps controller. There is Flux, there's Argo, and then we have another one in the Carvel project called Cap Controller that has all the Carvel tools just built into it. Those controllers can run the YTT program for you and maybe run other Carvel tools, and then take that result at runtime and apply it to your cluster. And that could potentially be a good way of doing things as well. We have a lot of people doing that in the community with VMware customers and etc. We do this even in some of our products. And so like Argo has a Carvel plugin that lets you do this. The Flux community right now doesn't have a Carvel specific controller, so you have to do it ahead of time instead. And that controller has this stuff built in.
Cool.
Yeah. But I think that's a great question, because it really gets to, okay, well, if we're really trying to improve our tool set, right? And if these tools are really as clean as you say they are, then I should be able to do them with all of the other good stuff that I'm doing right now already, right? And the answer is yes, right? If the tools are really clean, you should be able to use them in your existing workflows for sure.
So something about being a clean tool is not only at working with other Carvel tools, but working with other tools in a larger ecosystem. I like that.
So the fact that you can use Carvel very well with Flux, the fact that you can use it with Argo, points to the fact that it's solving specific problems in a clean way that integrates well with other stuff.
Cool. I'm sold. YTT seems cool. The only drawback that you mentioned that I heard at least was that it has a little bit of a high barrier of entry in terms of learning to use it. Is that true?
I think that any tool has adoption cost, right? If I were to compare the barrier of entry of getting into YTT to something like the very specific part of the monolithic tool that's called Helm, which is the text template programming language with the Sprig library, I would say that text template, it's very error prone. It's a lot like functional programming, which not a lot of people are very familiar with. And then you have to look at libraries here and libraries there. It's sort of confusing to find docs. And then the programs are ugly, honestly. Like it's and they're dangerous, and you have to do weird stuff with indentation, which is this like sub problem that you're always concerned about. I'm not to just say the spicy thing, which is that the actual templating and programming part of Helm, as good as the ecosystem is, as good as the libraries and honestly, the maintenance is not that great, because a lot of parts of the ecosystem have bit rot and are totally unmaintained and have weird bugs. Like that part of the tool, it just really sucks. And that's okay, because it's like, we needed this tool to get here, right? We needed this tool for the community to grow, for the ecosystem to build. We still will heavily rely on Helm, I think, for a very long time. And the maintenance team has even put in features to try and get around this very well-known shortcoming of Helm, which is that like now you have these post-processing engines at the end of things. Maybe those things are available sometimes. But that kind of tool has a very high barrier to entry and a very exhausting sort of, it's a very exhausting choice to continue to use something like that, right? It's like using a hammer that has a handle that's too thin, right? It's like every time you hit, like it just sort of hurts your hand a little bit.
So what I'm
using
hearing,
like a pairs of scissors that like it gets the job done, but only if the cutting strength is enough to get through the thing. Otherwise, the scissors, you know. And so
I'm hearing,
I think if you compare the similar kind of adoption costs to picking up something like YTT with the ergonomics of Starlark, which is Pythonic, a lot of people know that stuff. With the safety of the tools, it's not trying to do more than what it is. With the format, which is you can pretty much copy and paste a YAML document from a website into a text editor and then add a comment to it, and it's a valid YTT program that does something useful.
Yeah.
The readability, the fact that the text highlighting still works, that's not something that necessarily does work in Helm unless you have cool editor plugins. Right? Any YAML highlighter, the program is still going to look decent, and then you can add a better one, and now it adds all the Starlark stuff in the comments. So I would say that YTT is actually something that could potentially be very enjoyable to pick up. But of course, every language and every tool has its quirks where somebody could be like, oh, like that thing is way too big. Like, this part, I don't like it. You know.
So something you just taught me was the problem is not only about this complex configuration. The problem is maybe tools that have solved it in the past have pretty big shortcomings that YTT is coming in to fill. And then while the barrier of entry of YTT is not nothing, it's equal to and possibly easier than the barrier of entry to the other tools in this space.
I would say so. I think that one of the most approachable tools in this space right now is Kustomize. I've used Kustomize a lot. I've committed to Flux with various customized pages and stuff. We use Kustomize internally inside of Flux for a lot of things, which means like pulling apart their library and doing interesting stuff with their Go code. Kustomize is very opinionated. It's also Kubernetes specific. So you won't often find somebody using Kustomize for something that's not about a Kubernetes cluster. And that's because it's the programming language of Kustomize is based off of the Kubernetes API machinery, the strategic merge path, group version kind, namespace stuff. Everything needs to be kind of shaped in the Kubernetes way to use Kustomize. It's based on overlays, which is very approachable to people. And in the thing you're trying to do. And only just recently have they added this sort of conditional variant thing.
That was going to be my question. Yeah. With whether
so actually, you could not really do conditionals in Kustomize easily before because you would get into all these stacks and folders like everywhere as your number of conditionals went up, as the number of environments you try to support increased, and the number of options and knobs you wanted to change. Kustomize just didn't do that very well before. Now they have a feature called variants that's new. We just added support for it in Flux. And that's kind of solving that a little. Yeah.
It's pretty deeply built into the Kubernetes ecosystem where you can use the kubectl command -k with Kustomize.
I would never recommend using the -k flag because the version of Kustomize you're using is very important. You don't. I wouldn't recommend coupling the version of Kustomize you're using to your deployment target. So I would always just use Kustomize CLI if you can.
I want to say hi to Michael. Hi, Michael. Loving the context in this talk, Enlightning. So thank you so much for coming to hang out today. If you want, tell us your resolution or your theme for the year. I love, and Spheric, same to you. What's your theme? So I feel like we are good on YTT. We've defined it. We talked about what problems it solved. Are we ready to move on to another tool?
I would
Build, I
say
believe you said.
in closing about
Yeah.
YTT is
Mm-hmm.
go check out carvel.dev
We drop it
and
into the
click on
chat.
YTT and go to the playground. Yeah, here, I'll link the playground specifically for anyone
Awesome.
nerds in the chat
Which
who
is
are
everybody in the chat and me.
and want to play.
Mm-hmm.
Yep. So all you nerds chat can go and click this link, and it's going to take you to the interactive playground where you can start to learn about how YTT programs can be shaped, right? So yeah, conditionals, loops, overlays is one of the most important features. So similar to customized, YTT does those overlays. In fact, I don't know if we wrote that anywhere, but
No,
that's
in
something
fact, I
that
took away conditionals and loops. Mm-hmm.
in Helm that's good in YTT, that's good
Mm-hmm.
in customized. It's kind of customized doesn't really have values. YTT has values. Helm doesn't really have overlays. YTT has overlays. So, you know, it's kind of like pulling in the lessons learned from these tools that came before it, or at the same time, roughly. And it's just giving you the tools you need so that you can do the YAML shaping to solve the cloud native problems and stuff. And go play. There's the playground on the website.
That's the best. Awesome. Yeah. All right. So that's one of 7 that we're not going to go over all 7 today, but that's one of 7 Carvel tools. What's another Carvel tool that you want to highlight during today's show?
Yeah. So now that we've talked about configs, and we've talked so much about these Kubernetes objects, let's talk about a deployment problem, which is that I have my app, all of my source code.
Mm-hmm.
And I know that I need to tell the deployment system to go and run my app with some options. Maybe I need to add some environment variables. I probably have to set the number of replicas, or at least the way that I want the thing to scale.
Mm-hmm.
And then I'll probably also have to maybe set like a username or like a user number so it's not running as root.
Mm-hmm.
And, you know, while I'm at it, I should probably add some metadata so that it's not hard to find my app. So I better give it a name and some labels, and I better put it in a place in the system that's separate from everything else. So we'll choose a namespace.
Mm-hmm.
So cool, right? Like these all seem like reasonable decisions I'm going to have to make at some point. We're going to go to declarative config so that we can write comments about the decisions we made. We're going to comment the document. We're going to write a git commit. We're going to put it to repo. We're going to do GitOps. It's going to be good, right?
Yeah.
But at the end of the day, I got to build my source code, or at least package it into a container.
Mm-hmm.
And I got to take that container and I got to put it into a registry. And then all of that stuff about my app, I got to point it to my container.
Mm-hmm.
And that container is probably tagged at a particular version, or at least like some version tag. And maybe I don't just have one container, but I got 3 instead to run my app because I got a sidecar in there and I need a database or whatever. There's a queue processor, there's Kafka, something, anything, right? Okay, well, when I build my container at this version, at this point in time, it's going to be this tag. And then tomorrow, I'm going to update it because I love my user. And it's going to be a new tag. So I'm going to go to, I have to go and take the name of my registry and the name of my app, and then the tag that I push to the registry. And I'm going to have to make sure that that matches inside of my deployment YAML at some point. And this is going to be something that I'm going to have to do every time I update my app. And if my app is nice and small, and I'm changing it often, then that means I'm going to be probably doing this like 5 times a day.
Yeah, especially in a development.
I'm going to be editing YAML, right? And then every time I update it, is like, say I'm using multiple environments, like I'm going from doing the stage prod thing, or maybe instead you're just deploying right to production, but you have multiple environments still. You're deploying to Tokyo, Amsterdam, and Denver, right? Like doing that over and over again. And so you're maybe doing rolling updates or something. You got to go and update all these deployment YAMLs if you're using Kubernetes. You got to go and update all these app Docker Compose files if you're using Docker Swarm. You got to update all of these YAML files for AWS, all of these YAML files for Google Cloud Functions. Right? You made your container, now you got to go and update the thing. Again, this is a problem that you have with Kubernetes, but it's not necessarily unique to Kubernetes, right? Anytime, say you update the container in your build pipeline that like actually runs your build, that has all your build tools in it, because a lot of CI/CD tools now are container-based. Say you're using Tekton, say you're using Knative, which is not core Kubernetes. You need some way to update the image in your Knative service. And Kbuild is a tool that's really good at this problem. It has the ability to orchestrate your build and also find the versions of your container image in the registry and put the immutable reference to that image inside of your deployment configs, whatever it is. If it's a Kubernetes config, a Docker Swarm config, a Circle CI config, a Tekton, Google Cloud Functions, whatever. And I'm gonna give you a little bit of time to piece that down to the sweet neon bliss of our global
config.
Also, shout out to the chat today, man. We got like such an awesome, like, this is just a great community.
Right,
Awesome.
it's so warm and happy. So the problem is when you update your application, you have to rebuild the container image, you have to push it to a registry, and you have to update the configuration in many places. And this is a lot of work.
It is a little bit, yeah. It's a little bit
toil, even. Yeah,
it's definitely toil. It's something that could get in your way a lot. And so, what do people normally do? They might use like a little bit of sed, you know, which is a Unix tool that's just good at basically doing text editing. That doesn't sound structured or fun or safe. You might like maybe run a YQ Swiss Army knife command to update a Helm values thing, maybe, and then their Helm values thing does a bunch of templating and whatever. And you know, you could reuse a YTT program here instead if you wanted. That would be a pretty decent way of doing stuff, but you would have to write the program.
Sed or just write programs, write scripts.
Yeah, write scripts, programs, you know, all kinds of tools that are good at YAML slicing or something like that. So Kbuild already knows how to do this stuff for a bunch of different types of configs.
We have some comments in the chat.
Yes, always use the shot damage. Yeah.
Man. And then Pete says, I'm here too. Yay, Carvel. So maybe trust that the image tag won't change is one solution to this. Does that mean when you push a new image to the registry, you have the same image tag, so you're not acknowledging in your configuration that the image is now different? It's just pointing at a new one?
Something you could try. This is something that's great for local development because Docker, you can pull the tag, you know, like you can decide to say, hey, I want the newest version of this specific tag. But I will say that this is a very dangerous thing to lean on if you're trying to do rollouts. And the reason for that is that images get cached on nodes. And unless you're using a pull policy of always, or however you tell your orchestrator to do that, in Kubernetes, it's called a pull policy for your image, then you may end up with, you know, my app version 2 being an older image on some nodes and a newer image on other nodes with no way to tell Kubernetes to use the older or the newer version. It actually breaks the mechanism of the deployment and the rolling update. So I really highly recommend against using single tags to update images unless you are maybe like a software vendor or like an open source project that's just trying to give people a shorthand for getting the newest image for development reasons. That's what those kind of bubble up tags are best used for. But when you are deploying to a production system that should have rolling updates and should be able to track the specific artifact that's deployed into production, you should be using the most specific tag possible. And this is a great question because Kbuild is very good at this problem. In fact, it's so good at this problem, you almost don't need to think about it, because Kbuild will lock your image to an immutable reference that Pete mentioned called the SHA-256 version of the image.
Can we, I think you maybe said this when I was writing out the problem, but can we back up before we get into the specifics of what Kbuild does? Can we talk about the larger, talk about a step back and talk about a bigger picture?
Yes. Yeah.
Okay.
So
even while we're stepping back, can the Kbuild, it's not is it like Kubernetes build or something? What's the
probably
it's not an acronym, is it? Okay. All right. I'm not gonna add one word on it. Okay.
A fun, nerdy name.
Yeah. So what does Kbuild do at a big level before we get into the locking into the SHA?
Yeah, it will orchestrate your build tool.
Okay.
Find your immutable tag and update your configs.
Kbuild, what does it mean to orchestrate a build tool?
Yeah, there's lots of ways to build container images. The most popular one for sure is build.
Okay.
Even within Docker builds, there's actually multiple ways to do it. There's the traditional Docker build. There's the newer version, which is using BuildKit in the background. There's Docker BuildX, which is a different command line that has multi-arch support and a bunch of other things. Once you build images, you can push them around in a bunch of different ways. And then if you're not using Docker, you could also use Pack, which uses Docker underneath. Pack is like the way to use Buildpacks so that you don't have to worry about how your build is created. It just heuristically builds your container for you. You could use Maven, you could use Co, you could use a build kit inside of a Kubernetes cluster, which we have a kubectl plugin for. Check out the Tanzu build kit Kubernetes kubectl plugin. Really cool. You could use Bazel or Bazel. So there's lots of ways to produce container images. And usually when we're in a cloud native project, we have to write a make file or some sort of script to automate the fact that we made a decision about how to build our containers. We might not even use the same tool for all of them, right? And so we need some sort of program that helps people just say, build my thing, right? Build it. And now it's going to use this tool, and it's going to use this tool with these options, and you're going to end up with 3 containers. Kbuilds can do this with a declarative config.
So Kbuild, so this happens at runtime? Like when
this happens in development. Yeah.
In development. So Kbuild builds an image. How does it know what image to build?
You tell it inside of the configuration where to find the source code and config files for your build tool.
Okay, so it builds image, it knows your source code and it builds the image from source code in configuration file.
Yeah, so in your Kbuild config, you can be like, I have this container image for my app, and it's in /source/my app. And Kbuild will go to that directory and it will be like, okay, I'm going to use Docker build, or I'm going to use Pack to make this container image based off of your config.
Okay, so Kbuild will build the image using your favorite build tool. So like in your configuration, instead of listing the image, you list a path to the source code. And then Kbuild uses that to build the image from your source code, something like that.
Kbuild has its own configuration. Yeah.
Okay.
So
got it.
Yeah. Yeah.
And so
that's That is confusing because that's part of the problem as well, right? It's the second part of the problem is once you have your artifact, how do you get your deployment configs updated, right?
Yeah.
So you see, oh man, this is great that we have this moment, because the confusion and pain of the infrastructure practitioner or the DevOps person or whoever ends up with this responsibility is, oh man, like I built my container and I have to push it to this registry and I have to figure out what it's named and I have to figure out what it's tagged and I have to do this reliably with good release practices. And somehow I have to update my configs, right? Like it's this messy problem where you're gluing all of these things together.
Yeah.
And some of it is related to you changing your code and building things, which is sometimes a super long process. And other times it's just like you're trying to find all of the deployment things that reference the thing that you need to update.
Yeah.
Right. And that's both of these problems are unfun, but on different dimensions. One is just long and maybe you have build errors because of your own source code or your config problems or OS packages. And then the other dimension is like, oh, I have configuration complexity. And like you have to glue all of this stuff together and it's like your hands all sticky, right? So Kbuild has its own configuration for the build process. Yeah. And then it has in that same config a separate field where you can specify how to update the container images once you have, like how to update references once you have the artifact. Does that make sense?
So in the config, you're saying stuff like, this is the tool I want to use to build the image.
Yeah.
Maybe
this is
you're defining the source.
Code. Yeah.
This is where the source code is. Does it push to a registry?
This is what
registry?
The app is
Have we
called.
talked? That's what it,
This is where the registry is.
Okay.
This is what the app's image name is.
Okay.
This is what the tag should be.
And then you define it one time, and then everywhere in your config where an image is mentioned, it can get updated from one place. That makes a lot of sense. So
so what you do is you pass your build configuration and all of the options in Kbuild, and then you also pass. You can either do this in the same step, or you can do it as 2 steps using Kbuild. Once you have the image produced and in the registry, Kbuild can resolve it. So it can find the image and figure out what its immutable SHA-256 reference digest is. And then with that resolved tag, you can pass all of your deployment configs to Kbuild, and Kbuild will update your references wherever images are.
So what I'm hearing at a really high, simple level is that Kbuild builds the image using your favorite build tool and your source code, and it gets all that from the config, but it builds the image is the point. And then the second thing it does is it pushes the image to a registry for you, right? After it builds it?
That it can do, yes. That's part of the build. Yeah, it basically, that's like 1A. It can push it if you need it to be pushed.
Okay.
But the complete other thing that it does that's like that it's very good at, that's basically separate from this problem, is the resolving image tags and updating them in the places you need them to be updated. So resolve tags and update configs.
What does it mean to resolve a tag?
So even if you haven't built the image, you can go and look for a particular image in a registry. And like Pete mentioned earlier, you cannot know if a tag will change. Like you may be looking at an image that looks like it's the same thing, but it's actually a completely different image underneath because someone pushed a new one to the same tag. The tags in image registries are not immutable. But if you want a very specific image from a registry, you can always reference it by its hashed digest. That sounds jargony. It sounds even worse if it's the SHA-256 digest. But basically, people will say that when you use this technique, it's content addressable, and it's because the digest of a container image is mathematically unique. It is the only identifier that could reference that container image. So if you want the specific thing that you built at a particular time, then you can go and grab the digest for that tag. Kbuild will go and do that for you, and it will write it to a lock file. So it's it's called the resolved image tag.
So you can be sure that you're using the image that you think that you're using
at that time.
Yeah.
Yes. Right.
I like that. I want to say hi to Kormaju. I'm so glad, Kormaju, all the regulars are coming to set today, and happy 2023. I'm so glad you're here. And I just visited India. I was there in the last 3 weeks. So thanks for coming as always.
Your pictures and experience from India with your friend's wedding looked incredible, by the way.
Thank you. It was amazing. It's such a fun trip.
Yeah, maybe we can banter more about that later. So
heck yeah.
Image tags, right? That's what it means is we want to turn the tag into the tag right now into the digest that will never change. And this solves all of your deployment issues, maybe with tags rotating and changing, if you like accidentally do a new one or like misconfigure your pipeline or something. Even if you're using latest, like if you're never thinking about tags at all, if you use Kbuild, your version will never drift on you when you deploy to Kubernetes or wherever, because you're deploying with a digest instead. Which means that your rolling updates and all of the nice stuff that you get from your orchestrator will always function properly, even if you're not thinking about it, which is a huge benefit and a major safety thing. Like if I was on a platform team working with 30 dev teams and they were going to own the container builds, I would be scared that sometimes bad stuff would happen because they're managing their own tags. But if my platform tools included Kbuild, I would know systemically that Kbuild is giving those teams the safety that they need to get the full benefit of the container platform. So that resolving images thing, now that Kbuild can, sorry, I need to cough.
Okay, I'll just say hi to Nick the first one while you cough. Hi, Nick the first one.
Hey, Nick.
All the favorites are here today. Thanks for coming. And Lisa, to answer your question, I did not see any elephants. Maybe another time. I'll get back. Okay.
Elephants? Oh, no elephants.
Yeah, Lisa knows I have like a lifetime bucket list item to meet and hang out with an elephant. I think I'll cry when it happens, but I didn't. But it's important to me to do it ethically and not like in a touristy way. So I'm not sure how to make it happen yet. Yeah, but it's
such important animals. It's good. It's okay to have bucket list items that also might never happen. That's fine.
Yeah.
But we're going to try our best, right?
Yeah. So with Kbuild, we have the problem of when you update your app, you have to rebuild container image, repush it, update it in many places in config, use the image you intend to use. And there's a lot of toil and a lot of ways it can go wrong where you're using the wrong container image. So that's the problem that Kbuild is helping to solve. So you don't have to use sed or write custom scripts or any of the hacky things that people have done in the past. So Kbuild does that in 3 steps. So it'll build the image using your favorite build tool, and it'll build the image from the source code that you reference. And then it pushes the image to a registry, which seems optional. And then you then once that in your configuration files, it will resolve the tags and update to the latest image that it just built in the configuration.
Yeah.
And so
there's like 3, and then that last bit is like a 4th step, right? Which is like update all the places. But you would almost never need to resolve.
So it's like a 3 and a 4. Okay.
Yeah, you would never need to resolve the image tag necessarily unless you only needed the digest. But like you're always going to need the digest for something, right? To like update some configs. So that use case is really tied together. The only reason I mentioned 2 is optional, which is pushing the image. Is Kbuild has an optimization for local development. If you are developing with a local Kubernetes cluster, which is very common,
Mm-hmm.
sometimes your local cluster
Mm-hmm.
shares the image cache of your Docker daemon, which means
Mm-hmm.
that when you build, the content of your image is immediately available to your Kubernetes cluster if you can just address it.
Mm-hmm.
So Kbuild can also do local dev without pushing images. And the way that it does that is it makes a separate image tag that has the digest as the tag.
Mm-hmm.
And then you can use that immediately in like your Kubernetes cluster or inside of a Docker Compose config. Again, I really want to highlight that. Like you could use Kbuild to update your Docker Compose configs. So even if you're not using Kubernetes locally, Kbuild's local development workflow works for Docker Compose, which means it's not a Kubernetes specific tool necessarily. And this would also work with GitHub Actions. And it would also work with Tekton. And it also works with Knative, because even though Knative is not a core Kubernetes API, Kbuild understands how to find container images. Some other fun details, you can look at the configs again, carvel.dev/kbuild.
We put it in the chat, please.
Yes.
Thank you.
Let's go ahead
and I want to
grab
say, Abhishek's here. Happy 2023. We were so close in India. I almost got to meet Abhishek, but not quite. We just missed each other. But happy 2023. All the favorite people are here today. It's the best. It is making my heart sing. And then Koramaju, I think I can answer your question. So you're asking what kind of image when it builds an image, or is it Docker, Containerd? You build your container image based on your tool of choice, and that's something you specify in a kbuild config file. So you can use whatever tool you want to build your image, whether that's Docker or Buildpacks, or I think Containerd uses Nerdcuddle, that uses BuildKit. However you want to do it, you just specify it in the kbuild config file, and it builds your application container image.
That's all absolutely on the dot. I'm looking right now. I just linked the Kbuild docs. And if you look at building images, then all of the sections in here. Oh gosh, I was just looking at this. Where is the list of builders that are supported? Yikes. We can do this. We can do this. Building images from source. Okay. Well, I'm struggling to find the page that I was looking at just not that long ago. Build images. Here we go. Source.
I feel
Docker, BuildX,
Yeah.
Pack, the BuildKit CLI for Kubectl, which does all of your builds in cluster. Definitely check that out. Co and Basil, or Basil, however you like to say it. So
again, we've come full circle.
So notably, I guess Red Hat's Builda is missing from this list. And what else? Not much. Maven's missing from here.
Maven uses Buildpacks under the hood.
Yeah, so I guess you could just use pack for that instead. Yeah, just point right to the same build pack. Yeah. So yeah, pretty much, the entire ecosystem is supported. All the BuildKit stuff is really preferable, in my opinion, to use.
BuildKit stuff?
Yeah, just anything BuildKit based is like really good. So with the Docker file front end, that's getting down into the details and stuff.
Yeah.
If you don't know, you'll find out. You have cloud native problems.
Since I've done a Buildpacks show, and so that I've gotten familiar with the community, then I like them a lot, and I'm a Buildpacks girl, but I really just don't know BuildKit.
Oh yeah,
so maybe I'll feel differently once I get to know them.
All right, so if you wanted the benefits of like community tested solutions, Buildpacks is great for sure, and that's why we support Pack. Actually, now I'm thinking we should expand Kbuild to support Kpack, because we already support BuildKit CLI for Kubectl, which does the BuildKit builds in cluster. And it's all CLI extension based. For like it's not using you know, Go SDK stuff under the hood to reach out to these tools necessarily. So for at least for not for everything, like the CLIs are still required. So we could just add support for KPack, and that would be really nice, because then you could run your pack builds inside the cluster.
So
anyway,
this is actually an opportunity to talk about how open source works. So Carvel is an open source tool, and you just identified a use case that might be a good way to improve Carvel. So if you want to do that, then you can create an issue. And is that how you would do that?
oh, totally. Yeah, the governance for the Carvel project, there's a community call with open notes you can go and look at. You can join. If you have a fun demo, you can go and give that demo on that call. It's recorded and uploaded to YouTube, promote it, you know, from the community channels and stuff like that.
So if you're like, here's a feature that I would like to see in Carvel, I create an issue in the GitHub to request it. Maybe
if you were uncertain if you wanted to open an issue, you could go to the Carvel channel in Slack as well. So
cool.
It's in the Kubernetes.
Oh, okay. So moving on from K-Build, I'm a little worried because there are 7 tools and I have only this much space left. Are we talking about, how many more tools are we talking about?
Oh, we'll just only talk about CAP, and then we might mention it. Yeah.
Okay.
So before we move on from K-Build, I just want to point out that when you are building your app is not the only time that you have container image problems. You have container image problems when you are consuming other people's containers, when you are moving them around from one place to another. All of these times where, if say you're using a vendor's piece of software, like you want to install Kubernetes, but you want to do that in your air-gapped network. K-Build is really great for this because it can resolve those image tags for you, and then you can update them in the configs that the vendor gives you, or like whoever the open source project had some configs to run it. You can use K-Build to go in and find the tagged versions, update them to the digests, and then update your configs that you're actually going to deploy in your cluster. Because people don't normally use the digests inside of the configs that they distribute. It's just easier. So you don't have to use the build orchestration part of K-Build to benefit from it. Really, if you were using tools that K-Build does not specifically support for producing container images, such as Builda, or if you were using KPack to continuously build your tools, you can still use K-Build. And it still adds a lot of value because it's resolving those image digests and updating your images to pin them to the immutable versions. And so you get like rolling updates and all the stuff that is necessary for that to work. Does that make sense?
Kind of. So what I understand is K-Build, you run a command to say, I want to deploy this YAML, and it has K-Build written into it. So K-Build does its thing to update the images. So, and it looks at, and it's pointed to source code. So what you're saying is it can also, if your image uses third-party containers, it can watch those too. And what else can it watch? Was there something else?
Oh, just like if like you can just, the sources part is optional. The build orchestration part, it's a very big part of the problem.
Okay.
But it's not always the problem that you have. But what you always have when you are using container images is this tag resolution issue. Which is that the tag is not promised to never change. And so sometimes that's a good thing, but for container orchestrators, what they really want to know is what the exact version of the container is, so that they can do safe rollouts of stuff. And you should just have processes to find out when container images change, which you can do with Flux. So you always have the problem of resolving and updating your configs with this really long SHA-256 string that uniquely identifies your container that no one wants to read or mess with, copy and paste or all that stuff or script around. Kbuild is really good at that. And even if you are not building your own applications, if you're consuming containers at all and deploying them for yourself, then you already have the problem beyond point 3, which is you got to resolve the tags and update them everywhere. Kbuild does that in a Kubernetes agnostic way that works really well with Kubernetes. So.
Awesome. Good job, Kbuild. Good job, you. Great. So what's the last tool that we're going to talk about today?
Let's talk about CAP. CAP is fun.
CAP is fun. Does I guess CAP, my guess is that would it be Kubernetes application? App?
Oh, sorry. We have a question here.
Oh, great. Can we build and push to multiple containers simultaneously to Docker Containerd and container registries, Docker registries in Harbor?
Yes.
Great question.
Yeah, this is a great question. And it's really key to understanding this problem, right? Which is that we're not always working with one container, even though we might be working on a single application. So normally I would have a kbuild for each app, right? I wouldn't necessarily kbuild multiple applications together, even if they were not my application. Like if I was installing Prometheus and Logstash at the same time, or like FluentBit or something, I would use kbuild separately for each one of those things. But when I install Kubernetes, it also installs Grafana and a bunch of other containers that export metrics about the Kubernetes API specifically. And it's probably going to also install Prometheus operator. So there's literally like 6 containers in that one configuration. And kbuild can resolve all or none of those images if you want, right? You can do things like overrides. You can do static replacements to change images to point to your own registry. And kbuild will do all of that at the same time. You can build multiple images at the same time. You can do multi-arch builds by using like Docker Buildpacks, so that you're producing like multiple containers, like 4 different containers with a manifest list that's called the same thing. There's a lot of different ways to deal with this I don't just have one container problem. And a single kbuild config can do that. This is a really great question.
Excellent. Thank you, Komashi. Cool. All right. CAP.
So looking at CAP, the tagline for CAP, if you go to the website, is take control of your Kubernetes resources.
Okay.
So CAP is a Kubernetes specific tool.
Okay.
Right? And that's because when we are deploying to Kubernetes, the sort of default experience that you get with kubectl, with kubectl control, it leaves some things to be desired. It's a very generic experience that just kind of says, hey, I applied this thing for you. It tells you maybe if some things changed, but also sometimes that's not reliable. And what changed and what's the difference between the object in the cluster and what I'm doing right now, and what's the status of the object right now, and is it going to change? And stuff in Kubernetes is eventually convergent, even almost potentially convergent. It might just not converge, So what CAP solves is 2 problems. The first major problem is a same variation of what we have been suffering with all of our lives as infrastructure practitioners, which is how do we stay organized? How do we know what is together with other stuff? Because we're gluing a lot of different ideas into one cohesive problem we're trying to solve. And Kubernetes, it has a few high-level tools for this. The main one is namespace. There's also labels. But it doesn't tell you how you should use namespaces. It doesn't tell you how you should use labels. and even using them is a little bit quirky.
Mm-hmm.
But at the end of the day, if you are deploying your application, it might have multiple namespaces. It might share namespaces with some others. It's going to produce a bunch of different objects. A lot of those objects might not even be Kubernetes core objects. They might be from like various operators or controllers that are doing things that are configurations. This thing has like 50 objects inside of my one application. It's not fun. Because now when we look in the Kubernetes cluster, we have to read through the mess. Well, what CAP does, the first part at least, is it keeps track of what you deploy together. Right? So when you say, hey, I want to deploy these 50 configs, CAP does a little bit of tracking and bookkeeping to make sure that those 50 configs can all be found when you're like, hey, I want to check the status of my app. Can I inspect my application? Yeah. What's the question?
Before I have questions about that, but before we dig in on it, can we say what the second problem is so that I can close out the way I'm organizing? Okay, thank you.
I like this.
So the first problem is that it's hard to relate Kubernetes resources to one another.
Yes.
And then the second kubectl problem is what?
It's hard to know what the status of resources is and if they're all in a good state.
We've talked about this on past episodes. Know what the status of resources is. Okay. I'm going to say whether they're happy.
Yes, I like that. Whether the resources are happy, whether the controllers are satisfied, right?
Yeah.
Normally we think of that like satisfy the controller is like a technical thing, but if you just think about it more as like, has the controller finished lunch? You know, like is it satisfied?
Yeah. So you were saying that CAP relates resources to one another so that we repeat now what you said before.
Yeah. CAP is bookkeeping. When you deploy stuff together, you can tell CAP this is a single application, and all the 50 things that you're deploying in various namespaces with various policies, configs, and extensions and custom resources, all of it will be considered as one big thing. So when you say CAP, can you show me my application? It'll be like, sure, here's your 3 deployments in this namespace, and here's these configs and other policies in this other namespace. Here are cluster level objects, and here are these other cluster level objects, and there's this other namespace, and it shows it all to you in a really nice format. And then it also shows you whether or not all of those objects are happy individually. And
isn't that similar?
If you just ask CAP for like all of the applications in the cluster, it'll just tell you overall, like, hey, I have this app, I have this app, I've got these 5 other things, just at a high level. And these 4 apps are happy, and this add-on is unhappy, and this other add-on is happy, you know, like that kind of stuff.
Isn't that similar to what Helm does?
Yeah, that's one of the sub-problems that Helm as a big tool solves, right? So when we were talking earlier about what tools can be considered clean, so like what Helm sets out to solve is to give you an entire workflow for templating, packaging your application, distributing it, giving it a way to be installed and upgraded, and then indexing how many times you've installed things and where you've installed them and what options you've done. And it all does this as a single tool. So CAP is only solving part of that problem. CAP is not a package manager. CAP is not trying to program and template YAML. It's not trying to find your container images and give you immutability guarantees, right? It's not. There's actually a bunch of other problems you can solve too. It's like it's not trying to store packages in a registry. tool for that.
Okay.
It's not trying to do dependency management. There's another Carvel tool that's pretty good at that.
Okay.
Cap is only concerned with bookkeeping, saying, hey, we had this group of stuff and we installed it as this thing in this place, which is the last mile installation, upgrade, diffing part of Helm. And if you don't have a Helm chart for something, which is a huge ask, because remember we were talking about the adoption cost of Helm templates, and also just exhaustion of maintaining Helm charts. Helm charts are not necessarily the best way to author a Kubernetes package, but they're kind of the only way in an ecosystem level. So we're trying to change Carvel.
Okay. And I think Abhishek had the exact same question as me, but is it correct to say Cap is a successor of Helm?
Yeah, I would say no, it's not correct. You could say that Carvel experience is a successor to Helm.
Yeah.
Accurate. Because if you use all of these tools together and a bunch of other tools we haven't talked about today, you get an experience that I would say is competitive to, if not superior to, a lot of Helm stuff. Now, with any new tool to the space, right, you're not going to have the inertia and the ecosystem and the network effects, right? So like you'll never make a kind of like for like comparison. What I will say is that these tools are very well factored. So if you wanted to install a Helm chart, but you didn't want Helm lifecycle management, you didn't want Helm's storage stuff, you didn't want Helm's kind of inspection and dating tooling, and you liked Caps better, you could do a Helm template and then pipe it right to Cap, right? And then Cap would be keeping instead, right? So in some ways, that's a really clean part of Helm, which is that you can use the Helm toolset to get out of the Helm ecosystem, right? You can Helm template a chart and then get to a format that other tools can use with mostly no consequences. As you start getting into like Helm hooks and some of those things, it can get a little bit dicey, because now you're asking for Helm to do lifecycle management and like staged rollouts of your objects inside of a Kubernetes cluster. Cap has other ways to do that, which is an important part of the problem that it solves. So cool. I like the way that Cap actually approaches that issue. Yeah. So yeah, there's the two problems. I may have lied to you a little bit, Whitney. There's like kind of a third problem that Cap solves.
Okay.
Which is if you have ordering and dependencies and weird relations between your app's objects, or even with objects outside your app, just Kubernetes objects in general, Cap can do sorting and ordering and weighting between Kubernetes resources.
So it's hard to apply all your different resources in the right order.
Yeah. Yeah. In the right order.
In the right order. And we have a question there in chat. Will you answer, Kormaju, please?
Let's go pop that up here. Thank you, Kormaju. So does Cap represent free resources and container placements on hosts? No. This part of the problem, if you are in a Kubernetes world, is handled by the Kubernetes scheduler. The way that you can print out like what's happening here is with kubectl get nodes. You can look at also kubectl top will show you the utilization and saturation of your Kubernetes cluster. There are a couple of other Kubernetes specific tools that let you view utilization. There's even a fun like matrixy one called kubeops view from Henning Jacobs that I used to use a lot back then. But I don't know if it's been updated recently. But if you want to see and think about the usage of your cluster, that's not a problem that deployment tools like the last mile of Helm or CAP are specifically targeting. Thanks for the question.
Yeah. So, so CAP groups your Kubernetes resources together so you can deploy and access them at once. And based on the problem, you just
actually why this question came up now, because the word resources is maybe a little bit confusing. So when we say
objects,
it's like it is called a resource inside the Kubernetes API. But the objects, they're the different kinds of thing that you can tell Kubernetes to go and operate. That's what we are talking about when we say a resource. It's like the way that you program Kubernetes. So that's a little bit different than thinking about the compute resources of your cluster, like CPU, memory, or network bandwidth. We're not talking about that part. Which is mostly the scheduler's concern. When we are deploying Kubernetes resources, we mean we're making deployments, we're creating pods, we're making services, all that good
configuration, stuff. Secrets, for example.
Yeah.
That's a good point.
That was a really good question, actually, because that totally brought up a language discrepancy there. So,
Thank you.
Sweet. So we got our 3 problems. We now have CAP, which is going to do our bookkeeping for us. So I would really encourage people to actually just go and try this, which is like anything that you do kubectl-f, and then you like apply, like kubectl apply-f on like some directory of configs. Sometimes you have to like run that command like multiple times, because first, it has to make namespaces, and then once the namespace is in there, then the deployment can be created, and like the service account has to be created, and then like if you have custom resources, then the CRD has to be there first. So if you run a kubectl apply on a folder of resources, there's a good chance that it might not succeed the first time, and it might tell you a little bit of why, but that's painful. And this is something that we do a lot, right? We apply a lot of resources at once to a Kubernetes cluster because we want it all to converge. The reality is that because the API is convergent and sometimes you have dependencies between objects, it's not possible to do it atomically. So CAP is happy to go and do the same thing that you would do, which is go look into the cluster, into what dependencies there are, look at the API, reason about what things would need to come before what, say general assumptions like, oh, I got to put the CRDs first. I got to put the namespaces first. We can do the cluster level objects first. Then let's go and do the namespace objects, that kind of stuff. CAP knows how to do that already. And so if you do a CAP deploy -a, and then you name your application, then you your folder. Then it will go and take all of your resources. It's going to do the sorting and ordering. It's going to go and put the ones that need to be into the cluster first. Then it's immediately, as fast as a computer could do it, it's going to go and put the other stuff in. Right? So now the API is going to be referentially and from a dependency standpoint, it'll be consistent. So you don't have to go and retry and over and again. You don't have to script it into multiple steps. You can just say CAP deploy my thing. And all of it is going to reconcile as fast as possible. On top of that, CAP will tell you exactly what is happening inside the cluster as it's happening. So instead of there just being no output and kubectl is just hanging there until resources reconcile, or maybe you're like doing things that just goes into the cluster immediately, depending on your flag options, CAP will actually wait for all of your resources to reconcile to a point where, like Whitney said, we want them to be happy, right? We want them to be satisfied. And so we're not trying to deploy stuff and then have it fail, right? And if we deploy stuff and we have it fail, we would really like to know what's happening as it's happening. CAP will tell you when you put a deployment into a cluster, this deployment has been created. Now these replica sets have been created. I'm tracking this replica set. there are 4 pods. These pods are all waiting on pulling a container image. The container image has now been found in the registry. Now it's been pulled. Now the containers are starting. Now the containers have failed with the bad exit code. The deployment is in a bad state. And everything was like yellow or green up to that point, and now it's red, and cap has exited. And telling you, hey, there's a problem with the deployment, and it's not that the container image was the issue. You could literally watch it in real time. It's that the application exited. Another time you might do it, and you forgot to push your container image because you were using kbuild configs, right?
It's nice that you don't have to go chase it down and like, okay, it didn't work. Exactly. What's the pod name? How do I go find it? Yeah. Let me describe it. Let me look at the events. Yeah. It's just all like right there for you.
Comes out to you in real time when you're using cap by default.
That's
you can opt out of this stuff if you just want the other stuff in cap, but yeah, it's like it's a good default experience.
I have a couple questions around that. One is, I know with it's like a super huge application, the fact that it will tell you everything while it's happening can be a little burdensome because it ties up your command line. So can you not do that if you don't want to, or can it?
What's the flag? There's a flag you can pass to basically use. You can make silent output so that it just waits.
Okay.
And you can also just tell cap to not wait, and that's fine too.
And then the other question is, what if, does it only do this until it's all resolved successfully and then it exits, or is it always watching your application so that if in 2 hours one of my pod fails, then I know?
Sorry, 1 second. This is a great question, but I'm just gonna blow my nose.
Okay. Thanks for the mute. It's Kuramaju and Abhishek, do you all have New Year's resolutions? Or my family does a New Year's theme. So last year my theme was learning, which I can say I was pretty successful on. I like doing a theme instead of a resolution because a resolution feels very pass fail and temporary, and a theme is more like setting a priority for the year. But anyway, anyone who's watching, I'd love to hear the answer for the question. Welcome back. This year my theme is being present. Like, my life is so cool. I want to like make sure I'm appreciating every single moment of it and not too caught up in what's coming next.
That's awesome. And for anyone who said earlier, my theme is mobility.
Yes.
Finding freedom with my body. Yeah.
Java Grunts here. Hello. I'm trying to be more like you both. Oh, that's too sweet. I think that's a little, it's so flattering. It's a cop out. Oh, Tiffany's here too. Hi, Tiffany. Tiffany says same. That's nice. Hello. Wow, is this the best stream? Like, all the best people are here. I love it. Okay. So I just asked you a question about cap giving real-time updates. And so does it only do that until the deployment's up successfully, or if like 2 hours from now a pod fails, does it tell me at that time also? That's my question.
Yeah, so cap is the command line tool, and its main unit of work is to get everything to a happy state. So it's able to do that for all of the resources as part of your application. And you can even add, because cap has ways to do finer level inter-object like orchestration, you can even tell cap to monitor things that are not part of your app or make them part of like dependencies for deploying things to make things happy, which is really advanced and kind of fun. Like this is just a tool that takes care of you. Like, it's not a leaky, unorganized tool. It's like very capable of doing all of this object status waiting dependency stuff. But
I'm sorry. Okay.
Get you to all of your objects happy, then cap itself is like, great, I'm done.
I did my thing. Okay.
So if you want that cap logic to be constantly monitoring your application, then you can build things to run cap get status, right? Like, you could run a monitoring report, cap inspect, to make sure that your app is coming back healthy. Because when you run cap inspect on your application, it'll go run all the checks for all of the objects. And then cap controller, which we talked about earlier, is the GitOps controller that is Carvel specific. Similarly, if you used like Argo CD's Carvel plugin, then you can use cap's reconciliation. Oh no, you cannot use it there, I don't think. Anyway, if you use cap controller, then it will be using cap continuously to make sure that your application is deployed in a happy state.
Oh,
and
so the answer is no, cap does not do that, but another tool in the Carvel ecosystem does do that, and it's cap controller.
And it just uses cap for that, along with a bunch of other Carvel tools to make sure that your config is building the way that you want it. Yep.
Cool. Awesome.
Kormanju has another question. Can we run the Carvel tools under one place, such as Visual Studio or Lens? Yes. I mean, so we talked about how Carvel tools, there's 7 of them that we list right now. 5 of them are command line tools, and 2 of them are Kubernetes controllers. So the Kubernetes controllers you actuate using Kubernetes objects or Kubernetes resources that you put into the API. So those ones you would use like your Git repo or your command line to talk to them. And then the other 5 command line tools are there so that you can script around them, so that you can use them from the command line in your own workflows. And so
it sounds like they're built into your YAML files too, right?
Yeah, like the command line tools can work on the configs. And then if you need more orchestration around them, you can still put your usage of the CLI tools into a makefile or whatever IDE workflow file you're using. And so if you wanted to then be able to execute those things from something like Visual Studio, you would just use your normal programming language extensions, your normal IDE extensions to execute these tools. Hopefully that makes sense, right? Like if I write a makefile and I pull up VS Code or IntelliJ or something, IntelliJ already has tools that are capable of running my makefile. Or if I'm using Maven instead, then I can just execute these command line tools from whatever workflow file I have, and that's how you can get the IDE workflow to help everyone on your team not have to type on the command line or something. Hopefully that is helpful.
Yeah, does that answer your question? Kormanju had the best questions today. Thank you for that. Yeah.
Good question. Yeah. Sweet. Cool. Were you gonna say something, Whitney? I think you did.
Oh, I was just organizing the thought. So we talked about how CAP groups the Kubernetes resources together, and then now we're going through the specifics of that, or of some of the benefits of that.
Oh yeah, I mean the bookkeeping is a huge benefit, right? Kubernetes clusters are often things that we share with lots of people, even if we're not sharing them. We're often doing lots of things in a single Kubernetes cluster ourselves. And then there's all the platform stuff. So you end up installing hundreds, if not thousands of resources into a Kubernetes cluster. Once you've installed, your monitoring stack, your logging stack, your ingress and networking stacks, your policies for network and for RBAC and all of this stuff, and all of your add-ons and operators, and then you have your apps, and then the apps for the team that you have. So at the end of the day, when you do all that stuff, CAP can keep track of those individual things in a shorter list, right? In the same kind of list length that I just went rambling on, and only a paragraph long, even though there are thousands of resources. Then you can drill down into the status of each of those things easily.
So what I'm hearing is you might you definitely could want to use a cat for an application, but you might also use cat for like a monitoring stack.
I often use cap when I'm installing a new add-on because it actually has a confirmation workflow. So say you take like a 2,000 line YAML file that's gonna put this cool add-on into your cluster. You don't really know much about the add-on except for that it solves your high-level problem for whatever your platform is or whatever. Right?
Yeah.
And if you did that with kubectl, then kubectl would tell you about all the objects, and then it just says, hey, I put all this stuff into your cluster. What cap will do is it'll actually say, hey, you have these 5 objects at the cluster level and these 4 new namespaces coming into your cluster. These are all of the things in a tree view. This is what we expect to happen. Do you want to continue? And this saves me from having to read through the YAML file because it gives me enough context where it's like I'm probably experimenting on a throwaway cluster anyway. Like now I kind of know roughly what's happening. I don't want to know the details yet. I just want to have enough orientation. I'll read through 30 lines of objects.
And you're also saying you can see that before you apply it.
Yes.
Did you just say that?
So
that's
I can literally cap deploy monitoring stack a URL from the internet, and cap will go and grab that YAML file from the internet, and it'll spit out, hey, I'm going to do these 50 things. Are you okay with that? And by default, I have to then say yes. So if I've not given the -y flag and done that override because I already know what I'm doing, this is a very helpful workflow. And then, then at that point, say I'm in an air-gapped cluster, none of my container images are going to work, right? So I hit yes, and it goes and deploys all of the things, and half of the stuff is happy. But now I can see, oh, okay, I'm waiting on all of my deployments because they cannot pull the pods in the replica sets cannot pull their containers. So then I know immediately, okay, well, I got to go copy these 7 container images into my registry, or something like that. So like that workflow is super helpful. It's not just the stuff that you're deploying, that you manage on your own. Like it's very helpful for deploying other manifests.
Rad. So so when you deploy something with cap, so let's just say it's an add-on instead of a homegrown application. It's going to deploy everything in the right order. So for example, it'll make the namespaces first. So that's great because otherwise you said you might reapply the same file of resources several times. Cap will give you real-time updates about what's changing and whether it's happy. And so, which is great just informationally, but then if something goes wrong, you know exactly where it went wrong, which is not something that happens natively with kubectl. You have to, something went wrong and then you have to chase down the problem. You can use cap not only for your applications, but for add-ons, for observability stacks, for more than that. Any resources you want to group together. It's funny, I hear your dog. I don't know if my cat was in here meowing earlier. And then
we actually have a new pair of roommates, our friend Gabriel and his new dog Nova, who's a cute puppy that also is a little bit vocal. So we're doing some training.
They're cheering for us in the background. So you can also see cap will show you what's going to happen in your cluster before it happens, which is especially good for third-party stuff.
There's even an option where you can ask for the full text diff between the objects. So like if you're doing cap to update an application or update an add-on, then you can ask, hey, can you give me the difference as well? And it will show you in line, like just like a git diff, or if you use the diff tool, and it'll show you the specific things that are changing as well. So, but yeah, it's like really good for knowing what it's adding to a cluster, what it's changing in an existing application, if things are healthy. It's a great like kind of resource management experience that I think is definitely a step up from the default basic kubectl experience. I used to do a lot of like piping kubectl get with a label selector on all namespaces to a file, and then diffing that file against my Git repository. And that would like be really painful sometimes because like the objects wouldn't be in order, so you'd have to order them to like try and find a specific object to diff it against a particular file. And so that problem set, like really easily being able to do that over a large collection of resources that are all considered as the same thing is really helpful. And this is a Kubernetes specific tool that solves it in a generic Kubernetes way. So you don't need to be using a particular templating engine or a particular package management storage feature or anything like that to get the benefits of grouping your resources and inspecting them and diffing them and updating them with this powerful workflow. CAP just solves that particular problem and gives you a lot of like other escape hatches for really fancy lifecycle management.
Yeah. Is there anything else? I have a little room. Hopefully there's not too much more I need to say about CAP, but do you think we've captured it all here, or is there more to add?
We've captured it.
Oh.
Yikes. That was bad. It's a bad one. Yeah, I would say that we've pretty much caught the essence of the tool. I mean, it's really something that I think that the value add is very clear. Like you go and use this thing and you'll see immediately why you might want to be pulling it into your workflows more often.
The chat's loving your pun. Java said that was a golden explain. Good job. And Physpheric, you have puns for us every week. So
like that.
Cool.
Yeah. One of the benefits of it's like if you use Argo CD or Flux, it's in a lot of ways targeting the same issues that CAP is solving, right? Just with a very GitOps focused workflow. And so both Flux and Argo have CLI tools that allow you to inspect the Argo application or the Flux customization or the Flux Helm release. And these are ways of basically indexing resources together and keeping track of their status as a whole, whether or not the application or the customization is healthy. And then they have ways of inspecting things, tracing stuff, and taking it back to its source. So if you're like already using Flux or you're already using Argo, you have this problem solved really well in your cluster, right? Like everything is organized, it's indexed into the bucket with the resources it's supposed to be. There's dependency management stuff with Argo phases or with Flux depends on. So you don't necessarily need CAP. We did build our own GitOps controller, right? So if you're using CAP controller, then we didn't have to build something specifically for CAP controller to track and do all the bookkeeping. We just used CAP, right? And so like if you're using CAP controller, there's a CAP controller CLI that does some stuff, but under the hood, it's all using CAP. So you can use just the CAP CLI to inspect a CAP controller GitOps, kind of installation. And yeah, that's just like staying organized. Everybody's felt that pain, regardless of whether or not you were using Kubernetes. Your environment can really get out of hand. It can be really hard to track, like, is this virtual machine meant to be with this VPC, with this security policy? We're in AWS land. There's no containers at all, and we still have the same issue. How do we know that's labeled and supposed to be together? How can we think about those things that are related to each other as a whole? And CAP solves that problem really well.
Is it difficult to group the resources together? Does it take time to define, or is it a pretty simple experience?
Sorry, I was reading the chat. Can you ask again?
Yeah, there's a very nice message for you. Let's go there, Lisa. says, Leigh, you're obviously very passionate about Kubernetes, Carvel, and more. I've actually watched many of your talks at various conferences. Thank you for talking with Whitney today. A great session. Thank you, Lisa. That's so kind.
Thanks, Lisa. You're so awesome. Thanks.
My question was about the user experience with CAP. Like, does it take is it work to do this definition to like group the actual resources together?
Oh yeah, I think.
Or is it a pretty simple experience?
Yeah, it basically, you have to learn, a slightly different command line than kubectl. There's just like different verbs like cap deploy or cap update. And then, or no, it's just cap deploy. That's all you have to know.
Yeah.
And then cap inspect is like how you can find out about things. And then you just have to learn one more flag basically, which is -A to name your app.
Cool.
So that's about the level of adoption cost. Of course, you have to install it, which you can do through a brew repository or by distributing the binary or using Chocolatey or something.
Will you tell me one sentence about what cap controller is?
Yeah, cap controller is the GitOps controller that pulls all of the Carvel tools and even some non-Carvel tools together. So yeah, it's a GitOps controller. You get all the Carvel stuff. You get a Helm template. You have, I think we're adding Q in there too. There's customize in there as well. Yeah.
The GitOps controller to help you use Carvel tools.
Carvel and other tools. Yeah.
Okay. I think that's an excellent use of my last little bit of space.
Carvel and more. How about that? It's like.
Okay. So if anyone has any more questions, or if you want to talk about your New Year's themes, please drop those into chat. And oh, great, Tiffany put up some guides that she and Leigh wrote for Carvel, so definitely check those out. Maybe Leigh, will you repost that so that the YouTube side can see it too?
Oh yeah, for sure.
Thank you.
If I can figure out how to highlight the text. Here we go. 1 second. I got this. Almost.
And while y'all drop your last questions and comments into the chat, I'm going to do a recap of everything we've talked about today. So Carvel it helps ease the pain of deploying applications to the cloud. And what I've learned today is that's not just your homegrown applications, but also like third-party applications or anything you need to manage what's running on Kubernetes or what's running on the cloud more generally. So Carvel emulates the Unix process model, which is to break a large tool into small composable pieces. So you don't need to use the parts of it that aren't relevant to your particular situation. There's no bloats there. And then Carvel is a set of 7 complementary tools, 5 of which are command line tools, 2 of which are controllers. So we focused on 3 of the 5 command line tools, 3 of the 7 overall tools today. The first one is YTT, which stands for YAML Templating Tool. And so the problem it's solving is that the complex configuration, there is complex configuration for applications, cloud-based applications. So with multiple environments, multiple Kubernetes resources, multiple pods, multiple third-party resources pulled in, there can be like 15,000 lines of YAML, you said. That's remarkable. I didn't think I realized it was that big. So other tools,
like we were just talking about a small environment there, right? Like,
yeah.
Like if you get into big scale deployments and you think about all the Kubernetes they're using, it's like easily hundreds of thousands, if not millions of lines of YAML. Yeah. Millions.
Oof. So the other tools in this space are Helm and Customize, and those kind of came up a lot during our conversation today. And especially Helm seems to do some of these things that Carvel does, but Helm is one bloated mono tool. Is that what you said? When these have broken out some of the capabilities into smaller pieces, and in many cases have also improved on them. So YTT is a YAML native programming language, so you can add conditionals to your YAML. So not just conditionals, but loops and even functions. Like anything you can do in a programming language, you can add that logic to your YAML. And you do that in the... And overlays. Okay.
Yeah.
And important. And then you add the logic using YAML comments. So specifically Starlark language, which is a Python-like language. And so it is compatible with GitOps methodology, and all of these tools are, all of the Carvel tools in general are. And you can either use YTT to pre-compile and store that in your Git, or you can have it run, store the logic in your Git, and it can run at runtime. Either way works, but definitely compatible with GitOps. So YTT, the big thing I think is you can add conditionals and logic into your YAML files is what you can do with it. That's the bottom line with YTT. Then we have Kbuild. With Kbuild, you can build container images, resolve the tags, and update configuration files. It'll do all that for you automatically in one command. So so the problem is when you update your application, you have to rebuild the image, push it to a registry, update your configuration files in many places and many files. And it's a lot of toil to do all of that. And before it's been resolved with writing scripts, usually you said, or using the same tag for different images, which is dangerous. Pete talked about that. So Kbuild will do this in several steps. So first it will build a container image using your favorite build tool and from source code. And those things are both stuff you define in a Kbuild configuration file. And then once that image is built, it'll push it to your registry of choice, which is optional, but that in a production environment, you would want to do it that way. And then after that's done, it will resolve the tags and it will update your image in all the configuration files. So it does all of those things for you with the one command line tool. So you can be sure you're using the image that you intend, and it can also watch and resolve their third-party containers too. So, and then the reason you might not want to push your image to a registry is if you're doing it to a local development environment. So you don't have to push if you don't want to. You don't have to resolve the tags if you don't want to. But if you use the full features of Kbuild, you would do all of those things. And finally, we talked about CAP. And CAP is an excellent Kubernetes resource management experience. So the problem is that we have some shortcomings when we use kubectl. And one is it's hard to relate the Kubernetes resources to each other. It's hard to know what the statuses of resources are and whether they're happy. And it's hard to apply the Kubernetes resources in the right order. So with CAP, you can group all of your related Kubernetes resources together so you can deploy and access them all at once. So when we say Kubernetes resources, we mean stuff like deployments, services, configurations, secrets, pods, etc. So CAP will deploy them in the right order. So for example, it'll create a namespace before it creates a deployment that goes into that namespace. It'll give real-time updates about what's happening until it's successful. So unlike kubectl, which will tell you immediately that it's successful before it's actually done anything, it will tell you what's happening in order. So in kubectl, if something goes wrong, you have to try to figure out where it went wrong and what resource it happened with. Go on a hunt for the problem. With CAP, since it's updating it in real time, if it fails, it'll tell you exactly how and when and why it failed. So that is huge right there. You can use CAP not only with applications that you make, but with add-ons you're adding to the cluster, with observability stacks and more. And then what's cool is you can see what's going to change in your cluster before it happens. So it'll show you this in a Git style GIF. And you talked about using it with an add-on, like this particular feature. So if you want to add a tool to your Kubernetes cluster, but you don't know who made it or what's about to happen, you can use CAP and see what changes is it going to make to my cluster exactly before you agree to those changes and have it all happen. So that's CAP. It's amazing. And then you can use a CAP. We talked about one of the controller tools that's in the Carvel set, which is the CAP controller, excuse me. So you can use the GitOps controller to integrate all of these Carvel tools and more into your Kubernetes cluster or into your GitOps experience, we'll say, because it could be a multi-cluster experience.
Absolutely. Yeah, that's a really good point. And CAP controller does have support for multi-cluster. So yeah.
Cool. Do you think, was that everything? Is there something you feel like you want to add or that needs restating? What do you think on it? I'm going to say goodbye to Abhishek. Thank you. Thank you for the nice words. Abhishek says, wonderful session. Thanks, Leigh and Whitney. And
Thank you for coming.
yeah, and Abhishek's gonna go try CAP straight away. Actually, let us know how it goes. That's super fun. Yeah, maybe. And then Tiffany says, I need your focus and memory skills. I'd share them with you if I knew how. But thank you for the nice words, Tiffany. Is there anything else you got, or is it time to dance out the closing of the show?
No, I mean, Carvel, I think the tools for themselves, the docs are pretty awesome, honestly. They're still getting better. Just, you know, come try some stuff out. You know, I'm sure that if you are doing cloud computer stuff, you have cloud native problems. These are the kinds of tools that speak to me, right? When I felt pain before, when I have suffered for hours on something simple that I missed, and I just wished that my tools had taken care of me. And then I see tools like this, and I'm like, oh gosh, wow, what a great approach. What a fun way to hold that type of problem and kind of approach it. It makes me happy because I get hopeful that our practice, that us practitioners, that we can build a community, we can build habits, we can work with each other in ways that are going to produce better systems. We can make the stuff that we maintain, that we deploy, that we put out into the world better. We can make it better for the people who use it, for the people who touch those systems. We can make it better for ourselves, for the people who come after us, who never knew us, never understood the brilliant ideas that led to the complex solutions that look like horrible ideas in retrospect. Like it's all of those things. We can get to a better place, right? Let's level up with each other and find some peace tooling. So check it out, carvel.dev.
Yay! Yes, and Physeric says, great start to 2023. I absolutely agree. This has been a really fun episode. Thank you so much for coming. Thank you, everyone who watches this later. I'm looking forward to more this year. We talked a lot of, so next week, 2 weeks from now, we have an episode on Harbor, which is an image container registry, which will be super cool. And then I think the first week of February is going to be an episode on Helm. So we've talked, we haven't said the nicest things about Helm this episode, so I'll be very interested to explore Helm in an Enlightning episode too. That's going to be so fun. So thank you. You ready to dance it out, Leigh? Dance our goodbyes? All right. Here we go.
That was my dinner going to Harbor right here. And then
and this is your Helm.
Yeah.
Like this.
It's a great little track.